Okay. In the previous class, we have discussed about abstraction. Okay. As we told, like declaring a behavior without definition is what abstraction. An abstraction is used to impose some rules to the subclasses. And abstraction can be achieved through a keyword named abstract. And abstract can be used for methods and classes. If a method is abstract, then the method should not have any definition. If the method has just declaration without definition, then also the method should be abstract. And if at least one method is there in the class as abstract, then the whole class should be abstract. And abstract methods will be inherited even to the subclasses. In the subclasses, the abstract methods can be implemented or the class will be made abstract. For abstract classes, we cannot create objects. Okay, that's what we discussed in the previous classes. And even abstract classes can act as reference variables, so abstract classes can involve in polymorphism. And the only use of constructor in abstract classes is to support the constructor chaining. Okay, that's what we discussed in the previous classes. Now we'll discuss about the access modifier final. We need to discuss about access modifier final. What is final? Just final is a keyword and access modifier. Final is a keyword and it is an access modifier. Just final for a member is used to tell that it is the end and it is the last. Final for any member is used to tell that it is the end or it is the last for that member. Final can be used for attributes, methods, and classes. Final can be used for attributes, methods, and classes. Just let us see how it will be for a final attribute. Now, I'm just commenting all these things. I'll use them later on. But just temporarily I'm commenting all the classes. Okay. Now, let me take a class person. No. Now I have a abstract demo class with a main method and a person class. Let me define an attribute in the person class. Just int I equal to 10, and let me make it final. Let me make it final. Now let me create an object to person class. Let me make it ID. Final for an attribute tells that it should not be redefined. Final for attribute tells that it should not be redefined. If there is a value in a final attribute, then it should not be redefined. Final attribute value should not be redefined. If it is so, it will give a compile time error. Now, will it give a compile time error? Yes or no? Yes. Just because initially the final attribute ID value is 10, but it is being redefined from 10 to 200. For final attributes, the value should not be redefined. Okay? For final attributes, the value should be defined only once at maximum. For final attributes, the value should be defined only once at a maximum. What is telling? Cannot assign a value to a final variable ID. Just because ID already has 200. ID already has the value 10, but we are trying to reassign the ID with 200, but ID is final. If an attribute is declared as final, then that attribute cannot be redefined. The value of the attribute cannot be changed. The value of an attribute which is final cannot be changed. If we try to change it, then it will be a compile time error. Okay? Final means it's final. So once the value is assigned to ID means it should not be changed. That's what it means for an attribute. Okay? The value of final attribute should not be changed. If we try to change it, will be a compile time error. Now, are we changing the value of the attribute? No. What's the value printed here? What's the default value of ID? 0. Okay? What is telling? Variable ID might not have been initialized. Why it is giving this error means, okay, final attributes doesn't have any default value. A very important point. Final attributes doesn't have any default values. The compiler will not provide default values for final attributes. The compiler will not provide any default values for final attributes. And so, if the compiler is not providing any default value, let me provide it 200. The compiler is not providing any default value, but before the usage of ID I'm providing 200. Okay? Understood what I am doing? See, this attribute will not have default values just because it is final. So what I am doing, before using I am providing a value 200 to ID. Okay? Now will it compile? No. Why? That's what I am telling. It is final and this does not have a value. If it has a value, it should not be redefined. If it already have a value, then we should not redefine that. But do we have any value here? Will the compiler provide any value? Will the compiler provide any default value for ID? No. That means ID has a value. In this case, ID has a value or not? No. Now will it be valid in case or not? Are we just defining or redefining the value? Just defining the value. Okay? First thing, cannot assign a value to a final variable ID. We can define, this is correct. Okay, we can define a value, but not in a method. We should not define a value to a final attribute in a method. It's not a valid case. We should not define a value to a final attribute in a method. We can assign a value to a final attribute only at 3 places. One is at the place of declaration. We can assign a value to a final attribute only at 3 places. One is at the place of declaration. Second is in the constructor. And third is in an instance initialization block. We can define some value to a final attribute either at the place of declaration or in a constructor or in the instance initialization block. So only at these 3 places we can define some value to a final attribute. So we are defining a value to final attribute in a method, which is not a valid case. Now let me cut this and let me keep the statement in constructor. Now it's a valid case just because we are trying to define some value to ID. Okay, we are trying to define some value to ID in the constructor. It's a valid case. defining some value to a final attribute in a constructor is a valid case. We will compile and let me go to the classes. So the value printed is 200. Understood? For a final attribute, we can define a value in the constructor, but not in a method. We can define at the place of declaration, or even in the constructor, or even in the instance installation block. Now I have two constructors. Which constructor I am using for object creation? Non-conventional constructor. Then what is the value printed? 200. Okay. Most of the people think like it is 200, but this is a compile time error. Let's see why it is a compile time error. First line, variable ID might not have been initialized. At which line it is telling it is error? 18th line. Where is the 18th line? Here. That means it's telling like there is error in this constructor. What is the error? Variable ID might not have been initialized. Irrespective whether you are using or not, okay? The final attribute should have some value. Okay? The thing is, if we want to define a value to final attribute in a constructor, if you want to define a value to final attribute in a constructor, we should do that in each and every constructor of the class. If you want to define a value to final attribute inside a constructor, then we should do that in each and every constructor of the class. That's what I am telling. Am I redefining here? See? One second. But see, if I create the object using normal constructor, then what happens? This will be executed. If I create the object using augmented constructor, this will be executed. Is there a chance that both constructors are executed? No, right? So that's a rule.
So in this case, we can assign different values. Like
we cannot assign different values for an object. See, if I am creating an object, let's consider like if I am creating an object like this, then which constructor is executed? No argument. Let's consider like this. Which one will be executed? Are we reassigning a value to a final attribute for object? No. These two are different objects. For different objects, obviously values can be different, since this is a non-static attribute. What I am telling is, for an object, the value should not be changed. That's what I am saying. If you want to define some value in a constructor, if you want to define value to a final attribute in a constructor, then we should define the value in all the constructors of the class. Okay? If you want to define a value to a final attribute in a constructor, then irrespective whether we are using the constructor or not, we should define the value to final attribute in all the constructors of the class. Now, initialization block also. We can define some value to a final attributes even in the initialization blocks. Now, what's the value printed? What's the value printed? 100 or 200? This will be a compile-time error, just because for the same object creation, both instance installation block as well as the constructor will be executed. First, which one is executed? Instance installation block. Then, in the instance installation block, I am defining the value as 100, but after instance installation block, the constructor is executed. But in the constructor, I am defining from 100 to 200, which is not a valid thing. Either we should do it in the constructor or in the instance installation block, but not the both. This is saying like at this dot id equal to 200. At that statement, it is saying like already some value is there in the id, so you should not assign some value. So we can define value to final attribute either at the place of declaration or a constructor or an instance installation block. Not at two places. Okay, either at the place of declaration or in a constructor. If it is in the constructor, it should be there in all the constructors or in the instance installation block. But if we try to define some value at least at two places, in at the place of declaration or in constructor, at the place of declaration or in instance installation block, or in the constructor or in instance installation block. If we try to define at least at two places, then it will be a compile-time error. Okay, and this is about final for attributes which are non-static. Let me define final for attribute which is static. Let me define final for attribute which is static. Static final attributes. Now, let's see how it will behave. I have a static final attribute whose name is id, and I am assigning the value to that id in the constructor. Okay? What's telling? Cannot assign a value to a final attribute id. This is not the correct place to assign a value to static final attributes. Non-static final attributes can be assigned at the place of declaration or in the constructor or in the instance installation block. The static final attributes can have a value either at the place of declaration or in a static installation block. We can define a value to static final attribute either at the place of declaration or in a static installation block. Final static attributes can be defined either at the place of declaration or inside a static installation block. So now it will give the value 20. It will print the value 20 just because we have a final static attribute, and the final static attribute which is defined in a static initialization block. So the value printed is 20. Now let's consider that. Now what is the value printed? What is the value printed? 10 or 20? Definitely will be a compile time error just because we are trying to redefine a value to a final attribute. So once it is defined, we should not redefine the value. Okay? Cannot assign a value to a final attribute, final variable ID. So once it is defined, then we should not redefine the value. So the value printed is 10. So final non-static attributes can be assigned with value either at the place of declaration or constructor or instance installation block. Non-static final attributes can be assigned with some value either at the place of declaration or in static installation block, but not the both. Okay? That's how attributes with final, and even local variables also can be final. And one more thing, static final attributes are used as constants. Static final attributes are used as constants. Static final attributes are used as constants. If you want to declare some constant attribute in a class, if you want to define a constant in some class, then I'll make that constant as a static final attribute. Let's consider that. Static final pi equal to 3.14, and the naming convention for static final attributes is the static final attribute should be in uppercase. For static final attributes, there is a separate naming convention, it should be in uppercase. And there are multiple values in static final attributes, then the multiple values should be separated by underscore. Pi is one word and value is another word. Since there are multiple values, those multiple values are separated by underscore. This naming convention is specific to constants. It's not for all the attributes, it's specific to constants. All the characters will be uppercases. If there are multiple words, then multiple words will be separated by underscore. Multiple words will be separated by underscore. And even local variables can be final. Even local variables can be final. The only access modifier allowed for local variables is final. The only access modifier allowed for local variables is final. We have several access modifiers, but the only access modifier allowed for local variables is final. Sorry, it's a double. Was executed successful. It was compiled and executed successful. Just because final for a local variable is a valid case. Now, we'll compile. Will it compile successful? Yes or no? Will it compile successful? Yes? What is selling? Cannot assign a value to a final variable. What is the meaning of final? If value is if it is final, then it should not be redefined. Now, are we redefining the reference variable p? Yes, we are previously reference variable p was pointing to some object. We are trying to redefine reference variable p so that it should point the new object. This is not valid. Okay, wherever it might be, either for attribute or local variable, final will behave the same. Final variable should not be redefined. Here, in case of reference variables, redefining means just referring to another object or null. Final attribute or final local variable should not be redefined. Okay, that's what how final for a attribute. Now, can we have final attributes in the main method? Can we have final attributes in the main method? Yes. In any method or in any constructor or in any initialization block, we have local final variables. Okay? And can we have static final attribute, static final variable inside the main method? Can we have static final variable inside the main method? Yes or no? Can we have static final variable inside the main method? Yes or no? Why? Why it's not? Yes. See, static is also access modifier. What I told just now, final is the only access modifier that we can use for local variables. We cannot use static for local variables. We should not use static for local variables. Final is the only access modifier that we can use for local variables. Just tell like it's a illegal start of expression using static inside the executable block. Using static for a local variable is illegal. Using static for local variables is illegal. And this is about final as a variable. Final for a variable. Now, the next thing is final for a method. Let's see how a final method behaves. Let's consider like we have a final method Now, final for a method tells that it should not be overridden. Final method should not be overridden. Final method should not be overridden. Now will it give a compile jump error? Yes. Just because we are trying to override a final method which is a compile jump error. If we try to override a final method, then it is a compile jump error. Final method should not be overridden. This it is saying like test in employee cannot override test in person. The overridden method is final. So final method should not be overridden. So some of the interviewers in written test they will be asking like this, some questions like this. Now will be compiled and executed successful or not? Sorry. Now, will this be compiled and executed or not? Yes or no? Definitely, it will be compiled as well as executed. Final methods should not be overridden, but final methods will be inherited. Final methods will be inherited to the subclasses, but those methods which are inherited should not be overridden. Final methods will be inherited to the subclasses, but those inherited final methods should not be overridden. And we can use the access level static and final for the same method. We can use static and final for the same method. We can use static and final for the same method. It's valid. So can be compiled as well as executed successfully. I have kept a static final method test. Okay, now let's compile and execute it successfully. Now go to SRC. Let me have a sorry. Now, will it be compiled and executed successful? We have abstract method test in the person, so I have made person class as abstract. Okay, and in the subclass employee, I am overriding the test method. Now, is it a valid case or not? Overriding? Overriding is not possible for final methods. Then how I can implement test? Huh? See, if we go on making the classes abstract, there is no end. At least at one point of time, we should break the abstract. At one point of time, we should break the abstract and we should provide some concreteness. Lifelong, if you are abstract, means nothing. There is no use. So, at one point of time, we should provide some concreteness.
We cannot have final and abstract together.
That's good. Final and abstract should not be used in a combination. For a reason that final methods should not be overridden and abstract methods should be overridden for their existence. So, final and abstract should never be used as a combination. Final and abstract should not be used in a combination. Just because abstract methods should be overridden and final methods should not be overridden, which is contradictory. Okay? Even final may not be used for a constructor. Final should not be used for a constructor. This is the modifier final not allowed here. Final should not be used for a constructor. There is no use of final for a constructor. Just because if it is a final method, we can tell that it cannot be redefined or it cannot be overridden. Final methods will not be, constructors will not be inherited to the subclasses. So there is no way of redefining and there is no use of final for constructor. For that reason, final is not allowed for a constructor. Final for a constructor is not at all useful. Final for a method is useful just because to restrict from overriding. But final, these constructors will not be inherited to the subclasses, and there is no sense in making a constructor final. So final is not allowed for a constructor. Understood how final will be for methods? Now let me see final for classes. Let me see how final will be there for classes. Let me define a final class person. Now, final classes should not be inherited. Final classes should not be inherited. we cannot create a subclass to final class. Final class should not be inherited. Final for a class tells us it should not be inherited. Okay? Okay? Cannot inherit from final person. Just because final for a class tells that it should not be inherited. Now, let me go for the previous thing. Can we use abstract and final as a combination for classes? Can we use abstract and final as a combination for classes? No. Even for classes we cannot use. Just because final for a class tells that it should not be inherited. But abstract for a class tells that it's not complete, it should be inherited for completeness. For concreteness, abstract class should be inherited. But final class should not be inherited. So wherever it may be, abstract and final should not be used in a combination. Final classes should not be inherited, but abstract classes should be inherited for concreteness. So for that reason, since those two are contradictory, final and abstract should not be used as a combination either for methods or classes. Next, now we have discussed about final. Okay, now let's consider like I have an abstract class with the abstract method test. Now, can I call person as a 100% abstract entity? Can I call person as a 100% abstract entity? Yes or no? Can I call person as a 100% abstract entity? No. It is impossible to have a 100% abstract class just because of the default constructor. Because of the constructor which is non-abstract, we cannot have 100% abstract class. What do we need to do if you want to go with 100% abstractness? What we need to do if you want to go for 100% abstractness? Okay? The thing is, we should go for interface. Interface is an entity which is 100% abstract, which can be 100% abstract. Interface is an entity which can be 100% abstract. It's not always 100% abstract. We can make interface as 100% abstract. Let me define interface shape. Interface my shape.
Sir, then subclass is final, that can be inherited by superclass. Then subclass is final.
It can be possible. A final class can inherit other class, but final class itself should not be inherited. Now, what's the keyword between my rectangle and my shape? What's the inheritance keyword between my rectangle and my shape? It should be implements, just because those are two dissimilar entities. Let's consider like I have. No. By default, all the interface methods are abstract. By default, all the interface methods are abstract. Interface can be made 100% abstract. Okay, it's not like at every time interface is 100% abstract. Interface can be made 100% abstract. Interface can have attributes and methods. Interface can have attributes and methods. And by default, interface methods are abstract. By default, interface methods are abstract. By default, interface methods are abstract. Now, my rectangle implements my shape means this abstract method will be inherited from my shape to my rectangle. So, am I correctly overriding this method? Yes or no? Okay, let's see whether we are correctly overriding this method or not. But this is abstract method. This abstract method will be inherited to the subclass. Okay, and let us see how it will be. Now what is saying? Calculate area in my rectangle. Cannot implement calculate area in my shape. Attempting to assign a weaker access privilege. Still like you are assigning a weaker access privilege. But what is the access level here? What is the access level here? Default. What is the access level here? Default. But why it is telling you are assigning a weaker access privilege? Means by default a interface method will be public and abstract. The default access level for interface members. The default access level for the members of interface is public. The default access level for the members of interface. The default access level for the members of interface will be public. Okay. Now, what is the default access level for my shape? What is the default access level for my shape? That's what I told clearly. The default access levels for a members inside a interface will be public, but the default access level for interface will be package only, default only. The default access level for a interface members, the default access level for the members of interface will be public, but the default access level for a interface itself is a package or default, whatever it might be, whatever we call. The default access level for the interface as an entity will be package itself, but the default access level for the members inside interface will be public. So the default access level for my shape is package. But default for access level for member inside my shape, calculate area. For calculate area, the default access level is public. The default access level for an interface will be package itself, but the default access level for any member inside interface, okay, will be public. So by default, any method in an interface will be public and abstract. By default, any member in the interface will be public and abstract. So while implementing the interface methods in the subclasses, we should use the public keyword. While implementing the interface methods in the subclasses, we should use the public keyword for the method. While implementing the interface methods, we should use public. Just because by default interface methods will be public. Now, are we correctly implementing this? Are we correctly implementing this? The default access level is public, but public will be assigned if we don't keep any access level, but we have kept the access level as protected. Now, is it correctly implementing calculate area of my shape? Yes or no? This is correctly implementing, but this is not valid. Okay? The only access level allowed for the members of interface is public. The only access level allowed for the members of interface is public. The only access level allowed for the members of interface is public. The only access level allowed for members of interface is public. See, if we don't provide access level, the compiler will provide public. If we don't provide access level, then the compiler will provide access level as public. Or even we can provide public access level. But other than public, if we give any access level to the interface member, then it will be a compile command. The only access level allowed for interface members is public. It's specific to interface only. Don't apply the same thing to all the members. The rest of the members are different and interfaces are different. So, interface members, interface attributes or interface methods should be public. We should not use any other access level. If you don't keep an access level, then the compiler will make it as public. Either we make it as public or compiler makes it as public, it is irrespective. But the only access allowed that is allowed, the only access level that is allowed is public inside an interface. And can we have definition for interface method? Can we have a definition for interface method? Yes or no? No. It's impossible to have a definition for interface method just because by default interface methods are abstract. It's impossible to have a definition for interface methods just because by default interface methods are abstract. By default, interface methods are abstract. So we should not have a definition for methods inside the interface. Now, can we have static methods inside the interface? Can we have static methods inside the interface? Just if I ask something, don't tell the reason. You can tell the reason after telling the answer. But that's not the correct way of telling the answer for any interviewer. First tell the answer, then tell the reason. That is acceptable. If you just tell the reason, the interviewer will tell the same thing. Okay? I don't require why it is and how it is. I require the answer. I have posed a question like, can I have static methods inside interface? First tell yes or no, then tell the reason why it is yes or no. Okay? Now, can we use static methods? Can I have static methods inside interface?
Yes.
Can we have static methods inside interface? Yes or no? It's impossible to have static methods or final methods inside a interface for the reason that by default the interface methods are abstract. Just because the interface methods are abstract by default, and abstract should not be used a combination with final or static. We cannot have static methods and final methods in the interface. We cannot have static methods or final methods in the interface just because the default access modifier for method in the interface is abstract. By default, methods in the interface will be abstract. By default, methods in the interface will be abstract. By default, methods inside interface will be abstract.